Can you explain a little bit the issue of the scope of the universe?
It's really hard for people to understand how freaking big space is. We figured out that there were 10 billion trillion habitable planets in the universe. Now we've discovered that every star you see in the sky has a family of worlds orbiting it. There's definitely snow falling. There's definitely oceans washing up on beaches. There's snow-capped mountains. There's deserts. There's so many worlds. Each one has its own story. If you count up 5 of those, one of them has a planet in the right place in what we call the Goldilocks zone.
Think of how many stars he's telling us there are.
There are 400 billion stars in just our galaxy, and there's almost an uncountable number of galaxies.
Every other experiment in the universe would have to fail for us to be the only ones.
You have a giant, extraordinary claim, a claim that, if true, would be the greatest scientific discovery in the history of humanity. Whether the government lies or not has nothing to do with whether or not that's true.
Can you explain why it's important for us to understand what we've done to our planet in order to understand how other things could have done that to theirs?
We have the capacity now. We can actually see into the atmospheres of worlds that are 40 light years away, and we can see the fingerprints in the light of what chemical compounds are in the atmosphere. And we just need to stop for a moment and go, holy shit, that is amazing. A bunch of angry hairless monkeys, us, figured out how to see into the air of a distant world and then use that to figure out whether there's alien life there.
Hi, I'm Mayim Bialik.
I'm Jonathan Cohen.
And welcome to our breakdown. Today we're going to break down, do aliens exist?
And is the information we need as a human species to make sure that we survive available to us on other planets?
Today we're going to be breaking down the actual way that scientists are actively exploring life on other planets. We're talking to theoretical physicist and astrobiologist Adam Frank. Adam has written many incredible books about our human experience, our human understanding of the intersection of science and spirituality, and also just plain old hard science. We're going to be talking about what is possible for us to understand about aliens, if they have visited, if they're going to visit, and what we can learn about ourselves from our exploration of other planets and other atmospheres. Let's welcome to the breakdown, Adam Frank.
Break it down.
Adam Frank, welcome to the breakdown.
It's my pleasure. Thank you for inviting me.
We're really excited to talk to you. I'm extremely excited to talk to you.
But anybody's excited to talk to me.
No, but like, I'm a huge fan of the Little Book of Aliens. I just, I got so much out of every page. And mostly I want to talk about equations, and Jonathan would like me to start not with equations. The place where we'd like to start, and you know, I'm just going to preface this by saying, like, I've read every single page of your book. Like, so I'm going to ask you things that might seem a little bit like alien softballs, but it's because we want to start a conversation with you.
Yeah.
And, you know, we had Lou Elizondo on, and people lost their effing minds. Like, they lost their minds for Lou Elizondo, you can imagine. But we're very interested in many aspects of your work. But let's start with this, Adam Frank. Are we alone in the universe? Are we it?
Well, I'm glad you asked. The answer is, as a astrobiologist, as a theoretical physicist, as, you know, a human being, is I have no freaking idea, right? I mean, we just don't know. And there's this intuition we have that the universe is so big, you know, there's squazillions of stars, that of course what happened here must have happened somewhere else. But actually, you know, the problem is there's a whole bunch of processes that go into the evolution of life, you know, abiogenesis, making life from non-life, evolving more complex life, multicellularity, the evolution of nervous systems, et cetera, et cetera. And we really have no clue about the sort of, when you combine those processes, what is the probability? How hard is it to get that to happen? So in 2016, Woody Sullivan and I, who was like one of my mentors when I was coming up, we wrote a paper where we looked at all this amazing new data we have about exoplanets, about planets orbiting other stars. And we figured out that there were 10 billion trillion habitable planets in the universe, right? And now 10 billion trillion, that's a lot of, habitable zone planets. That's a lot of places where nature could run the experiment that led to us and run it elsewhere. We'd expect like, well, okay, did it happen anywhere else? The problem is if the odds of all those processes working out to lead to an intelligent civilization is less than 10 billion, 1 in 10 billion trillion, right? If it's 1 in 100 billion trillion, then you're SOL because you've run out of planets, right? I mean, if you buy a lottery ticket with 1 in a million odds, if you buy a million lottery tickets, but the odds are 1 in 10 million, then you probably are not going to win. So we just don't know those odds. So that is really the problem. And that's why we have to do the work. My intuition, which is worth, that and 50 cents won't get you a cup of coffee anymore. My intuition is that, yes, there's so many planets that you'd have to prove to me what's the bias? If it happened here once, what's the bias that nature has that with all those planets, it didn't happen somewhere else? Now, let's assume that it has happened somewhere else. That still doesn't mean that there's anybody close to us, especially if you're going to start talking about UFOs and UAPs. And it certainly doesn't mean that even the galaxy itself, which has 100 billion stars, has anybody there now. Because one question is, how long do civilizations last, right? We have been around for about, as a technological civilization, about a century, 2 centuries?
It's nothing. It's nothing.
Right. And even if you were around for 1,000,000 years, which would be unbelievable compared to how long we're lasting, and we're not doing very well right now, as I don't need to tell you, that even if every civilization on average lasted 1,000,000 years, the galaxy right now, when we're looking, would probably be pretty sterile. There wouldn't be, there'd be dead civilizations, and maybe we could detect remnants of that, but there probably wouldn't be a whole lot of people around. So, there's a lot of things that go into it once you start trying to think about it really carefully and really scientifically, which I find when we get to like UFOs and UAPs, most people are not thinking about it, really carefully and thoughtfully.
Well, one of the things that I love about your approach is you are able to hold both of these conversations and many more conversations. So I'm going to quote from your book, which I might do a lot today. And what you said is the only way that we are the only civilization in cosmic history is if the odds of forming a civilization elsewhere, like on another planet, are so small, meaning every other experiment in the universe would have to fail for us to be the only ones, correct?
Right. Yeah.
And the place where, I know you've gone before, like a lot of people would be like, well, that's because God chose us and we're here and we're special. And I was actually talking to my 16-year-old about you and about your book, and I was explaining to him that there definitely are interesting things about our planet. The fact that we are not completely water, we're not completely gas, we're not completely rock. Like there is something very special that we don't know. We haven't necessarily detected other planets that look like ours in terms of a mix of like water and land and enough land that you could. And my son was like, but why didn't it just stay water? Why didn't we just evolve there? Like, was it because that there was enough land that we got to evolve to be able to walk on, our 2 feet? Can you talk a little bit about why we don't have to turn to the God explanation and why there are other possibilities?
Yeah, well, again, so first of all, we have to differentiate between life and intelligent life, right? Because, one of the interesting things, if you look at Earth's history, is pretty much the planet is, cools down, right? So the Earth falls as a big molten ball of lava. It eventually cools down, the crust forms, water is delivered via comets, you get an ocean, right? Pretty much almost right after that's done, life appears. So based on that, and there's a lot of sort of physics and math we can do about that, but it does seem like life was pretty easy to make, right? And that argues, you can argue that probably, microbial life may not be hard to form at all. That might be anytime you even give, a planet half a chance, you're going to get microbial life. Now, it then takes 3.5 billion years of evolution before you end up with us, before you end up with the first intelligent technological civilization. So that is kind of a question like, why did it take so long? But, in terms of so I just wanted to point that out when we talk about that, like, Earth may not be special at all when it comes to just getting life together. But when it comes to getting, the processes of evolution, what are the things that might make us unique, might make us special, and might still have allowed, you don't need to turn to like a miraculous occurrence to have it. Like one thing, we just published a paper on this. So there's a number of processes that it looked like were important to get multicellular life, to get complex life. One of these, and this just blows my mind every time I talk about it, when the planet was born, there was no oxygen in the atmosphere. Right? We did not have an oxygen atmosphere.
What was the atmosphere? Like, explain it to people, because people will be like, what does that mean?
Right. So when the Earth was born, it had an atmosphere that was almost entirely nitrogen gas, which it still is. It's still, mostly nitrogen gas and carbon dioxide. What happened? And then life formed, and for 1 billion years, 2 billion years, it was still carbon dioxide and nitrogen. There was almost no oxygen in the atmosphere. So now, first of all, why does oxygen matter? You could not have animals with big brains. Your brain uses a lot of energy, right? Oxygen is like this super powered chemical for driving fast metabolism. You will just not, on a planet with just nitrogen and carbon dioxide, you just don't have the chemical batteries, so to speak, to be able to allow the kind of things that you need for, like, first of all, multicellularity even, but certainly anything with a neurological system that is thinking hard, right? So no oxygen, probably no intelligent species, right? No intelligent technological species. So you don't get oxygen. What happens? How does oxygen form? Life does it. Life evolves a new form of photosynthesis, a way of taking sunlight and turning it into energy. It had already done that. It had already invented one form of photosynthesis, like, almost immediately. But then it around a billion or so years after life starts, a new kind of photosynthesis emerges, which uses water as a substrate, takes water, breaks it apart, takes the hydrogen to make a sugar, and farts out the oxygen. So the oxygen, now the important thing about this is it allowed life to explode, right? Because suddenly there's so much water to use for photosynthesis.
That's when all those ferns came around. So many ferns.
Yeah, but this is even before the ferns.
That's
Life
right.
is still microbial at this point.
Right.
It's where all the phytoplankton comes from.
Right.
So like they're just having a party. And that's where you get, first of all the life. You get lots of life, just lots of microbes. And then you start filling up the atmosphere with oxygen. That is what you needed. You needed another couple of billion years of that to be able to eventually lead to, cells getting together to make multicellular life, then to make things that were, sort of body, animals, metazoans, what they call, and then eventually leading to, dinosaurs and more really complex organisms and us. So that required, right? First of all, that required life to figure that out, right? And then also one thing that may have been really important about this was having continents, plate tectonics, right? You needed the continents to be getting dragged around and reassembling. We can talk about why that was, but it seems like that's a really important part of the story too. And it may be that's really rare. Like, most planets in our solar system don't have plate tectonics. And we can talk about why, but the important thing is they don't. And so that may be one reason you don't have to invoke God. It may just be that, Earth had the right set of circumstances, enough water to allow something like photosynthesis or this kind of photosynthesis to happen, but not so much water that there was no land, because land turned out to be important. And then you need the land to be moving around. So it may be that, the planet had to be right to allow the sequence of events that led to intelligent life.
Mayim and Bialik's breakdown is supported by Element.
Element helps anyone stay hydrated without the sugar and other dodgy ingredients found in popular electrolyte and sports drinks. Electrolyte deficiency or imbalance can cause so many problems: headaches, cramps, fatigue, brain fog, weakness. Element is a zero-sugar electrolyte drink mix born from the growing body of research revealing that optimal health outcomes actually occur at sodium levels 2 to 3 times the government recommendations. Each stick pack delivers a meaningful dose of electrolytes. There's no sugar, no artificial colors. Element is formulated for anyone on a mission to restore health through hydration, and it's perfectly suited for athletes, folks who are fasting, or anyone on a keto, low-carb, whole food, or paleo diet. We love Element to help us replenish electrolytes the quick and easy way. Jonathan is always doing some sport that causes him to sweat a lot. He and his son absolutely love it. And as I say, every water bottle that used to just taste like water now tastes like watermelon or chocolate or any Element flavor that Jonathan has used the previous day.
Tastes absolutely delicious.
From health experts, everyone from famed Stanford neuroscientists to functional nutritionists, to moms, exercise enthusiasts, heavy sweaters, sauna sitters, and those who want a dynamite no-sugar margarita or mocktail, incorporate Element into their daily routine. Get your free Element sample pack with any purchase at drinkelement.com/Mayim. Also try Element Sparkling, a bold 16-ounce can of sparkling electrolyte water. Try Element totally risk-free. If you don't like it, they'll refund your order, no questions asked. Again, for your free Element sample pack, go to drinkelement.com/Mayim. That's
drinklmnt.com/MAYIM. My Bialik's Breakdown is supported by IQ Bar, our exclusive snack sponsor.
IQ Bar is the better-for-you plant protein-based snacks made with brain-boosting nutrients to refuel, nourish, and satisfy hunger without the sugar crash. Their plant protein bars are packed with high-quality ingredients to help keep you physically and mentally fit. IQ Bar is totally free from gluten, dairy, soy, GMOs, and artificial sweeteners for a natural anytime snack. Try any of their 9 delicious flavors, including mint chocolate chip, chocolate sea salt, banana nut, toasted coconut chip, lemon blueberry, and peanut butter chip. With over 20,000 5-star reviews and counting, more people than ever are starting their days on the right foot with IQ Bar's brain and body boosting bars, hydration mixes, and mushroom coffees. When IQ Bar sent us their ultimate sampler pack, one flavor stood out for me, and that was coconut chip. But Jonathan does not let me eat them because he eats them all before I get to them.
I do not like to share these bars with Mayim at all.
You don't want me to even offer them to a friend. If someone's in the house, like, hey, does someone... Jonathan's like, no, don't offer the IQ bars.
No, hand them some other bar. These I need to hoard. They are so good. I am so picky about bars.
You're so picky about everything that goes into your body.
I have spent hours in the supermarket reading all the different ingredients and seed oils and palm oil, and first ingredient is sugar or brown syrup. These are so clean. They're so delicious. 2 of them, and I'm packing a ton of protein. I started packing them for my son because he's trying to increase his muscle mass and pack on some protein. These are so delicious. My personal favorite is the mint chocolate chip.
Right now, IQ Bar is offering our special podcast listeners 20% off all IQ Bar products. Plus, get free shipping. To get your 20% off, text BREAKDOWN to 64,000. That's it. Text BREAKDOWN to 64,000.
That's BREAKDOWN to 64,000. Message and data rates may apply. See terms for details. I want to just keep talking about these. They're so good.
Based on kind of the mathematical probability that you talk about in your book, there's really no reason for us to think that we are the only ones.
Right.
There's no reason to think that.
No.
So we are not the only ones.
Well, that's a...
Here's the thing about Adam Frank. He likes when I say it in the negative. He doesn't like when I say it in the positive.
Well, it's just, I'm a scientist, right? And the beauty of science is like, I'm not going to say something I don't know.
For sure.
I can talk about the hypotheticals.
Okay,
but,
fine. So, okay, fine. Let's try it again. The probability of us being the only ones is very, very low. And the probability that it never can happen would negate our existence. Like, we're here, so it worked once.
Yeah, exactly. Right. And so then the people who are pessimists. Now, also, can I just ask, when you say do you mean life or do you mean intelligent life? Because to me, either one is freaky deaky. I don't think we have this thing like, oh, we got to have intelligent life for us to be amazed. Like, to me, you form a microbe. If we find one microbe, all bets are off.
For me, I'm interested in any environment that facilitates any life form. Because I believe in the processes of evolution. I'm very patient. I'm
Right.
super patient.
Right.
But I think when we talk about what a lot of people want to talk about regarding other planets, yeah, they want to know, am I being visited by someone? Is that real?
Right.
Is the experience that happened to me real? Am I being watched? Like, what are these things in the sky? So in that sense, yeah, I think that people are very curious about what are the ways that we might be able to detect intelligent life that is able to visit us, get
probe
into probe us, things like that. But I think it is enough as a starting point of a conversation to say it happened once, and simply by the astronomical mathematical probability of what we understand now about the universe, unless you are invoking God, there is no reason to believe that we're it.
Yeah, so let me give you my version of that. Okay, so like, given how vast the universe is and how many planets that we've discovered. See, that's really the key thing. When I was just a young pup in graduate school, we didn't know whether there were any planets orbiting any stars. It could have been that our solar system was a freak and that most stars don't have planets. And this is like a 2,000-year-old question. The Greeks were beating each other up about this, the ancient Greeks. And then in 1995, we discovered the first planet orbiting another star. Our instruments got that good. And then, now we've discovered that every star you see in the sky, when you go out and look, has a family of worlds orbiting it. So once that discovery was made, then we know that, the universe is full of planets. And so what I would say is, in the universe entire, yes?
This was, I think, as of 2012. I want you to walk us through this a little slower, because for you, this is just like what you do on an average Tuesday.
My lunch. Yeah.
Every star. So when we I'm going to give you the super basic. I was not raised in a science house. My parents were English teachers and first generation Americans. Like, my grandparents literally believed, I think, that it took 7 days to get this whole shenanigans going. So when I was a kid, I looked up in the sky and I knew that I was one of 9 planets, because I'm that generation, right?
Right.
And I'm on a planet and there's orbits and there's like a gravitational pull and we're all circling and we circle ourselves and we circle the sun. Great. And when I look up in the sky, I just see pretty. It's so pretty. There's so many pretty, sparkly things. And if you were to ask me what those were, even probably well into my 20s, I'd be like, they're big balls of like gas, or like you can't get close to them. Like, they're stars. There's a million stars, right? Like, God will make you as numerous as the stars in the sky, right? I'm into it. However, what you're telling me is that when you look up, you see stars, and every star is its own
solar
thing,
system.
Its own
part of the solar system. So let's like unpack that for a while, right? Because this is my thing. Everybody wants to go UFOs and UAPs because they think that's the exciting thing. And, as we're going to find out as this goes on, I'm, very skeptical that UFOs and UAPs have anything to do with life elsewhere. People are like, oh, womp, womp, womp. Like, I'm so sad. I'm like, wait a minute, man. Let me tell you what we do know, because it is freaking mind-blowing. You don't need UFOs visiting you, to have like the most recent scientific results blow your mind. So, okay. So stars, you're right. Stars are giant balls of gas, but, undergoing nuclear fusion, producing, huge amounts of light. But what we didn't know, planets are the stuff that orbits them. They're either small and rocky, or they're kind of bigger and gaseous, like, Jupiter. But the bigger gaseous ones have moons around them that are also interesting places that you might have life. So anyway, up until like 1995, we had no idea whether there were any other planets orbiting other stars. And it was possible that forming planetary systems was really hard. People back in the day sort of had these theories that said, like, no, it's almost impossible to make a planetary system. We're just lucky. So 1995, we discover our first exoplanet. Now we know, after doing all this research, that every star in the sky, as I said, holds. So you should go out at night and look at this. You should do this experiment. You should go out and look at a star. And what you have to do is you have to imagine, like, oh yeah, there's, you've seen pictures of Mars. You've seen pictures of, Venus as they went by the cloud. But Mars, let's focus on Mars because there's pictures from the ground on Mars, right? Mm-hmm. Every one of those stars has worlds orbiting it that are like that. They're places. Every one of those stars has worlds orbiting them where, now again, I don't know about life, but there's definitely snow falling. There's definitely oceans washing up on beaches. There's mountains, there's snow-capped mountains. There's deserts, so every one of those stars has worlds. There's so many worlds. Each one has its own story, right? So that is the beginning of just the mind-blowingness. The universe is full of worlds. And then if you count up 5 of those, 1, 2, 3, 4, 5, one of them has a planet in the right place, just, in what we call the Goldilocks zone. It's not too close to this star so that it's just burning up like Mercury, and it's not too far from the star that it's just a frozen ice ball like Pluto. It's in what we call the Goldilocks zone or the habitable zone. And that is a place where you could have liquid water on the surface. And we think liquid water is essential for life. So 1 out of 5 of those, man, has got a planet just waiting.
That percentage, for the non-scientist in the room, that percentage is enormous because that's 20%. But think of how many stars he's telling us there are.
There are 400 billion stars in just our galaxy. Our galaxy is like city. It's like, our galaxy is like New York City, right? And you live in the Bronx or whatever, That's our city. There's 400 billion stars in just and there's almost an uncountable number of galaxies, right? But just in our city, there's 400 billion stars, and 20% of those, 1 in 5, has a planet in the right. They all have planets, and 1 in 5 has a planet in the right place where liquid water could exist on the surface, and therefore could be a good place for life to form.
We did an episode recently, and the topic of the vastness of the solar system was discussed.
Yeah.
And what the guest was explaining is that the probability of there being the multiverse, and I know we're making a leap here, where
go for it though, baby. Let's run.
Where there are multiple versions of our lives happening simultaneously is possible, given the vastness of the probability of inhabitable planets. How do you respond to that, understanding that you are hedging to say that you are, want to talk about things that are provable? But if we go theoretical for a moment, how would you respond to that?
Also, keep in mind you're responding to Deepak Chopra when you are responding to this.
Deepak Chopra, buddy. If I meet you in a back alley, we're going at it. We're throwing hands. So the multiverse, let's talk about the multiverse for a second. Now we're going to somewhere totally off. And I don't know how much you want to go on this. The multiverse is this theory about cosmology, about universes, about the birth of the universe. And I am not a fan. I'm not a fan. To me, there's a whole thing about what has happened at the frontiers of theoretical physics that I think is really problematic, where people are just going off, no connection to data anymore, just, playing. They're somewhere between doing like pure math and physics, and they're not doing either one very well. So I'm not a fan of the multiverse. And you can see in my writing, I've gotten into arguments with people about this. It's a beautiful idea. It's funny because, I was the scientific advisor for Doctor Strange, with Scott Derrickson. And that was the beginning of the Marvel multiverse.
Correct.
Right? And so, we talked a lot when I met with them doing the script writing. And I was like, look, guys, I think this idea scientifically is crap, but it's great for writing, right? I mean, it's great for science fiction. It's and it goes back and really, it's part of our imaginations, right? I'm right now reading the Vimalakirti Sutra, Buddhist sutra from 2,000 years ago, and it's a multiverse. It's a Buddhaverse, but scientifically, there's zero evidence that that's true. And I just want to, which it depends on how you feel about it. Like that's either a bummer or not. But again, I just want to say this universe, the one we live in, is already so freaking amazing. Who needs a multiverse? Like, we got all these planets. What happened on all these planets?
So maybe a good bridge for this is one of the questions that people have when we talk about aliens, when we talk about UFOs, is a lot of what science presents is, here are the reasons that we need to be carbon-based. Here are the reasons that the materialist view of, things travel at the speed of light, and that's how we perceive them. we can understand certain things about wormholes, but here's a limitation to wormholes.
Right.
What if, and this is like a big what if, and I'm curious how you respond to this. Along this kind of line of thinking about multiverses and all these kind of like sexy, kind of sexy components of, the border between science fiction and physics, and
Right.
also conversations about, astrobiology. What if our perception about the way things should be perceived is not the whole story? Meaning, it makes sense to me. I loved how you explained, for example, why carbon-based living makes for, mobile joints and movement and things like that. Why we haven't seen a wheel evolve, right, in our existence. We keep having to create it, but there could be worlds where, wheels independently evolve as part of an organic structure, right? All these things make sense. But my question is, what if approaching it this way is leaving out the possibility that there are other modes of communication, there are other modes of transportation, there are other modes of functioning that we don't have access to? And so all of our, kind of like measurement instruments are extremely important. And I want to get into more of the details of how we actually do look for life on other planets. But what if this notion of like, oh, well, the wormhole's going to collapse and so you can't travel through it. What if there's a species that can stop a wormhole from collapsing and they're able to, like Doctor Strange, step into different times? They are able to slice into reality through portals because, look, there's a probability for an electron placement that we know we're guessing where it can be at any given time. In theory, what mystics, what gurus have been saying, and what a lot of theoretical physicists say is that everything exists everywhere all at once, right? And we have our perception, but what if it's not the entire story? How do we frame that?
That is a great question. That is a really deep philosophical question, and I have a strong interest in philosophy. Actually, that book you have there is actually not my last book. Recently, last year, myself, physicist Marcelo Gleiser, and philosopher Evan Thompson published a book called The Blind Spot,
Right.
Why Science Cannot Ignore Human Experience. And I am very interested in that. So what's weird is you're going to find with me is that on the one hand, I'm like totally hard-nosed scientist. I'm like if I'm asking a scientific question, I expect us to, obey the rules of science. People are like, oh, that's so limited. It's like, science is a way of interrogating nature, like asking it questions, getting into a conversation with nature that we can hear and understand the answers. But I'm not somebody who says science explains everything. Like, when you go see Shakespeare and you are profoundly moved, like that's not just because, I can figure out the neuroscience of your brain and, I can explain, the title of that last book was about experience, how important experience is, and beginning with what is given in just experience. Experience, as we say in the book, is not reducible actually to science. But that doesn't mean right? Like when you ask about that, when you ask the question about a wormhole, you're framing your question in terms of science, right? Science does seem to be our absolutely best way of interrogating the physical world, the world where spaceships would appear, the worlds where, the world where there might, the equations of relativity, which Einstein derived, which we know are useful, are powerful for looking at, the sun, for black holes, and can be extrapolated to talk about wormholes. That's the right way of sort of talking about that. When people want to say like, well, what about extra dimensions and aliens? Because there is that whole with aliens, the idea of the dimensional hypothesis. They're not from other planets, they're from other dimensions, right? Well, that's still getting framed in terms of the physical world and questions you would ask about dimensions. Like dimensions is an idea from science. And we have probed, lots of people have pushed the idea that there's more than 3 dimensions. And it turns out there aren't. There's no good reason to think there's anything more than 3 dimensions. Even time, which we think about as being a 4th dimension, that's actually kind of metaphorical. It's a mathematical metaphor. But that time is not like space. You can't go back in time, right? I can go left and right, up and down. You can't go backwards in time. So I am totally amenable to asking the deeper questions about about the nature of experience and how there are things that can be true, that are not provable by science. But for me, now you're entering the realm of silence, right? So there's there's Wittgenstein, right? And Wittgenstein in the I can never pronounce the Tracticus, was this, incredibly detailed description of what math can do and what it can't do. There were 7 propositions. The last proposition was that which can't be spoken of must be passed over in silence. And, some people have interpreted that to mean like, well, you just can't talk about that stuff. What I would say is that, there's a different place to examine that silence, and that tends to be spiritual paths, right? Poetry, music, where like descriptions fail. Words are going to fail because our experience overflows them. But if you now try and say, well, now I want an accurate description of, what's in that silence, it's like now you're back in the world of physics, and I'm going to use physics again. So does that make sense, what I'm saying?
Yeah, totally.
Yeah.
I think we're at a point in time where people are trying to have science interpret some of that human experience, because the philosophers and mystics have talked about the multiverse and other dimensions, and that could be altered states of consciousness, and wanting science to then interpret or explain it. And where I get stuck a little bit is like, at one point, the tools we had for science only showed us a very limited view of what we can see now. So we know that our tools are constantly expanding, and what science is able to explain is constantly growing and giving us a better picture of what is quote unquote real. So I think, how do you reconcile, well, science can explain this now, but is constantly evolving and changing, and when we look back at what it was able to show us before, it was only a small sliver, as a way to sort of bridge that silence or that some of these more philosophical ideas.
And if I can just sort of add to that to flesh it out a little bit, what comes to mind is Dr. Neil Thies, who, was the first to identify fascia as connective tissue that literally, runs through the entire corpus, right? And what he was able to experience and then describe, from a neurophysiological, perspective, was something that energy workers, mystics have long, for thousands of years, have talked about, right? That there is something, there is something that runs through you, that the basis of acupressure, the basis of meridians, the basis of even aspects of chiropractic, which I don't like to get too crazy with chiropractic, but the notion of meridians, of connectivity, of these kinds of things, those things which we used to dismiss as that's hokey, Neil Thies was able to say, no, this is like an actual thing. It's an actual organ system, right? It runs through the entire organ system, and things that touch you in one place can touch you in others, right? And another example, that we have, I mean, even Einstein himself said there are limitations to what this can do, and we need to use imaginary numbers to be able to imagine an explanation for how we describe certain things, right? So the greatest physicists that taught me everything that I know, right? Niels Bohr, like the names that I so revered, I didn't know they had an entire mystical understanding of the impossibility, right, of the human experience. So I think that's what also we're interested in. We love that you can speak to these things. Can you sort of help us understand this in these realms?
Yeah. Okay. So for example, I have my acupuncturist. I go and have an acupuncturist is also a urologist, is an MD urologist, and we have these conversations all the time about all right, that's not a nerve cluster you just hit. There's no nerve cluster there. What is that? So I certainly think science absolutely, as science, if you're trying to describe the physical world, you always have to be open to the fact that what we've discovered today, is going to be only a certain view. Right. And, so I'm not what's called a physicalist, right? People
Sure.
like Sean Carroll, they're very much, I'm a physicalist. All that you can, that exists is physical.
Oh, Sean.
But, there's Hempel's dilemma. This is a famous dilemma in philosophy that, if the only things that are physical are what physicists identify, What do you do in 50 years when they identify something else? So there's a problem there. But I'm also, I think we have to be very, very careful here, right? Because human beings love to fool themselves. And we've been fooling ourselves for a zillion years. And science, the methodologies of science turn out to be the most potent for not fooling yourselves. Because, there's a lot of, we want the sense of connectivity. We want life is hard. As a Buddhist, the first principle from the Buddha gave was life is suffering, life is difficult. So there's the way in which we're kind of grasping at answers and solutions that'll make us feel better in some sense. So, I certainly agree that, it may be that meridians and the things that Chinese medicine empirically has known for, a few thousand years, eventually, physiology will understand sort of why this works for so many people. But at the same time, I just think you have to be super skeptical and super careful about trying to manifest what is often, in spiritual practice, something that occurs in the interior of experience, right? And make it a physical thing, right? Have a physical theory for it. What's interesting is James Maxwell Clerk, the guy who invented, Maxwell's theories of electromagnetism, brilliant physicist, was, deeply religious. He was a Presbyterian. And I learned this when I was writing my first book on science and spirituality. And somebody, wrote an article saying like, Maxwell's stuff proves that, God exists. And he said, that is a stupid way of going about your religion, right? If you have a sense of the divine, if you have if you have a spiritual sense, if you have an experience, because I'm all about experience, if you have an experience of sacredness, don't turn to science to justify it, right? Because science is constantly changing, right? It's experience. So when I wrote that book, I was really asking about this experience of, for lack of a better word, the sacred or sacredness, which has nothing to do with the supernatural. It's about the experience of there being more. I think you should be very careful about trying to impose that on, sort of the descriptions about physical reality.
Once we kind of use science with a lowercase s to try and explain everything, it gets kind of messy. And this is a place where, I often, kind of get tripped up because people do believe all sorts of things. And we do know that belief in and of itself is a powerful medium. Mm-hmm. And we are also learning more about what placebo means, right? Meaning we know more about intention now than we did before. There's some really unbelievable experiments about the intention of the experimenter impacting patients in ways that if you don't have that intention, it doesn't, right? What does that mean?
Right.
We're particularly interested also in near-death experiences and the abilities that people come back with, right, after these kinds of experiences. I wonder if you can, if we can return a little bit to, more what you actually get to study. First, I'd love for you to speak to the giggle factor, which I had never heard it called the giggle factor. Can you talk about what the giggle factor is and how that sort of, allows us to speak to what people do believe is happening with aliens visiting our planet and how we can transform that into a way that we actually can talk about life on other planets?
Right. So the giggle factor refers to SETI, the Search for Extraterrestrial Intelligence, which began formally in 1960 when Frank Drake took a radio telescope, pointed it at two stars, and listened for any kind of radio signals that were clearly non-natural. And there's ways to define that. So that was the beginning of SETI. He didn't find anything. He only looked at two stars. And then but it got a lot of press. The press found out about it. And so that was the origin of SETI. And, NASA was interested in it for a while, but it was always marginal, right? And so at some point we should talk about the Fermi paradox and everything that goes into that. But so what happened is that SETI, a number of times people tried to get SETI off the ground as a real going scientific concern, really get it funding. It's never really had funding. But the problem was always that, because of UFOs in particular, and the wackiness of UFO culture, it got associated with UFO cultures, which it never had anything to do with. It was about the scientific search for signals, radio signals, traveling across space from other planets. And so there was this thing called the giggle factor, which kept killing the attempts of NASA to raise, or NSF, National Science Foundation, to put some money into it. So like in late 80s, NASA wanted to do a big project to, build more radio telescopes to study SETI. And some senator got up on the floor and said, we're not going to be searching for little green men, and literally put legislation in that killed any possibility for funding. 5 years later, same thing happens where the congressman from Nevada stands up and says, if I want to see life in the universe, I just have to go down and look at the National Enquirer, buy a copy of the National Enquirer because I can see UFOs right on the, again, associating this scientific search with all the rigor that happens with science. And we should talk a little bit about standards of evidence and what sets apart what scientists do and the kind of UFO stuff, or at least what's been done with UFOs. So anyway, this giggle factor was this giggle meaning like people would mention, oh yeah, SETI, and the pioneers of SETI, Jill Tarter, Frank Drake, Carl Sagan, they all had to put up with this. They're trying to like develop this scientific discipline, and everybody's kind of like raising their eyebrows, or after they leave, they're all giggling. And it's only recently, my generation, or actually even younger than me, and I was at the meeting when the giggle factor in 2018 finally began to get dissipated. But now both the search for life, but particularly the search for intelligent life, which we would now refer to as the search for techno-signatures, which is the complement of just searching for any kind of life, which is biosignatures. That now, it's still, some people will still raise their eyebrows about techno-signatures, but overall, NASA has acknowledged that, yeah, of course, if we're searching, NASA's all in on search. The entire astronomical community is all in on searching for life. So why would you exclude intelligent life if you're doing that, right? So the giggle factor now has finally beginning to dissipate. But it was really the association with UFOs that made it kind of laughable.
I think a lot of people might be surprised to hear that NASA's always been all in on trying to find life on other planets. What do you think people who dispel this are afraid of?
Dispel what? I'm not sure what you mean.
The notion that we can search for life on other planets, that we should be, that there is a scientific rigor to it. What would we say to those people?
Well, I think it was part of history. Because really the thing was, there wasn't much you could do back in the day. It's only with the discovery of exoplanets in 1995, and then the development of new telescopic capacities. It's only technology that now, circa 2024, circa 2010 even, that you could do it. So actually, like in 1987, when I went to graduate school, SETI was marginal. There wasn't much to do. It required a huge number of assumptions. And even though like my, one of my professors, Woody Sullivan, did it, I didn't choose to do it because I just thought like, there's not much to do here. I respected that he wanted to do it. And I was happy to talk about the people who were doing it, but it wasn't that you weren't ready to really have a search for life. There wasn't much to do scientifically. Now there is. And, with science, what people have to understand about science is to ask a question, you have to have the tools to answer it. If not, it's just, speculation. It's armchair speculation, right? It's only in the past 15, 20 years that we've really developed the technology that I can say, look, here's how I'm going to answer your question. Is there life on other planets? And that's the real transformation.
How do you reconcile what's been happening in the public square in Congress, the congressional hearings, all these people who have worked at the Pentagon or for U.S. defense claiming that there are spacecrafts, there are biological samples, and that every country in the world has some form of program and or evidence. Obviously, we haven't seen the evidence, but how do you reconcile those very fantastical claims with the science that you have seen and understand?
Yeah. Okay. So I covered this in the book, right? So the first UFO sighting is the first really popular UFO sighting. It breaks into public consciousness, 1947, right? 1951, and it creates a craze. Like, you know, nobody's ever seen UFOs, and all of a sudden, after this story comes out in 1947, there's like 900 sightings in a year.
And actually, I was talking to Jonathan about this, because if I can just sort of flesh this out a little bit. So what happened in 1947 was an erroneous newspaper headline.
Yeah.
Where basically, you know, for sexy value, the thing that this pilot saw was described as a saucer. And what it was that he was flying around like you do. I believe that he was actually looking, it was Kenneth Arnold, right? He was actually looking to see if he could find debris. He was flying about, and he saw very, very, by all of his reports, which again, it's one person reporting. We're just listening to what he says he saw, which is not a scientific exploration. But what he did was he tracked their approximate speed based on literally their movement between two mountains. He did a calculation, and he said, there's no way that this is anything that I can describe from my knowledge of how planes move or how helicopters move or how anything moves. And once the interviewer started talking to him from the local paper, he sort of started describing, well, it was kind of flat. It was like this. And they were like, it's a saucer. He saw a flying saucer, which, like, people don't even use cups and saucers anymore, but that's in theory what it looked like. But it was an erroneous headline. And then all of a sudden, everybody's seeing them everywhere. We went from no one seeing them to everyone seeing them. Wait, Jonathan has a problem already.
So where this explanation is going is it was placed in the public consciousness, and then people are starting to make these things up. However, it feels slightly different now when there is video evidence and people who are supposedly have more credibility than others working for U.S. defense and governments. Is it simply that same pattern?
Well, so this is something really to unpack for a little bit. So first of all, let me say, let me make my statement. I am all for open, transparent, scientific investigation of UFOs and UAPs. It's the only way you're going to figure out anything. So let's absolutely do it. Please don't take money from astrobiology, because we barely have enough to, we're running on fumes, right? So, but sure, the budget is pretty big, have one less F-15 or something, or, don't put in the $12 trillion toilet seats and fund it. And I'll follow it carefully. And then let's talk about what that would actually look like, and what this idea of standards of evidence that need to be applied to it. But you were specifically asking about this whole thing with the videos and the military.
The military, the government, the videos, the medals that no one can explain, and scientists.
There are no medals that no one can explain.
But they say that there are.
No, but they never get them, and they've been saying that. So let me just here's my little story. Right, 1947, first UFO sighting. Project Sign, I think it's called. I think it was originally called Project Saucer, which was a bad idea if you're trying to calm people down. 1951 or so. The guy who's running it, I've forgotten his name, Edward something. He runs that program, retires, writes a book in 1956, where military guy claiming that there was a special report called the Assessment of the Situation, which said that these things were interplanetary, right? Nobody ever can find the report after years of finding. Sound familiar? A military guy saying like, "Oh, I don't have any evidence, but I've heard about the evidence. I haven't even seen the evidence, but I heard of other people who've had the evidence." And it's like, decade after decade of people saying, "Well, I didn't see it, but I've heard about people saying it." And at some point, this is all you have, right? You can't make an extraordinary claim like, "Oh, I have medals that no one can ever, that no one has properties I've never seen. There are government warehouses full of spaceships," and then be like, "Yeah, but I can't show them to you." And they say, "Oh, did you see it?" "Well, no, I didn't see it, but I talked to a guy who saw it." Like, I wish I had the ability to do science that way, right? Like, "Hey, man, there's a giant dragon living in my basement. Oh, can we see it?" "Oh, no, you can't see it." "No. Actually, I never saw it. My friend saw it." So what has happened, and what is it? Sean Kirkpatrick, he, who was one of the heads of the was the head of the Pentagon's UFO panel, UAP panel recently. He was shocked when he started talking to these military and intelligence officials. And he asked them, well, what evidence do you have, right? No evidence, just hearsay. And he said, like, look, man, you're an intelligence officer. You know, like, you can't work this way. You can't make these claims unless you have evidence. We wouldn't talk about dangers from Russia, you know, and act on them based on. And what he said is, like, what you've had decades of this culture of certain groups of people in the intelligence and military community who have convinced themselves this is happening. And you're having a giant circular conversation where no one's ever seen the data. They've just talked to people who talked to people who talked to people who saw it. Because for every military guy that you're going to pull up who's going to say, we have biologics, I can find you a military guy who says, that's insane, right?
Okay, but also you seem to have a trust of the government that I do not. Meaning, I'm willing to entertain that there is information. I'm willing to entertain it. I didn't say no, that's true. I'm willing to entertain that there may be information, because we already know that the government was lying about even their research into legitimate concerns that had come to their attention, right? We already know that they were not honest about that. Yeah. They're also not honest about a lot of things.
And I talk about that in the book, right?
For sure. So for me, I mean, I think once you insert, you know, a lack of trust, then of course you're going to say this stuff's going to be well protected. No one's going to get to see it. I mean, I'm just going to be really honest. Do you think that there's just like a giant infiltration of people who work for the government who believe in aliens, and it's just that's just where their neuroses are coming out?
The government, like, first of all, I completely agree. Do I think the government is going to tell anybody the truth about it? No, right? That is not what I'm saying. What I'm saying is you have a giant, extraordinary claim, a claim that, if true, would be the greatest scientific discovery in the history of humanity, right? So whether the government lies or not has nothing to do with whether or not that's true. You got to separate those out, right?
Right.
And also, as many people have pointed out, right, you know, there is no the government. There's lots of government agencies that all hate each other and they're all in competition with each other. So the idea that a secret like this, right, you know, could be kept for 50 years is really stretching the credibility of anybody who's ever actually worked in the government and saw that how porous the government is. Show me any secret that's been actually kept, completely kept for 50 years. And again, like you said, the idea that the government's been infiltrated, you know, you have a bunch of people who work in the government, just like there's a bunch of people who work at the post office who believe in UFOs, right? And it's not because they have any evidence. It's because, you know, they like the idea of UFOs. They're inclined to believe in UFOs. Fine, that's fine. And then because of that, and they work in the government, when somebody in the government said, hey, I knew about a guy who knew about a guy who saw something, they're like, yeah, we got to get to the bottom of this. Right. That does not mean that the government has UFOs, you know?
What do you make of the videos of spacecraft that have been revealed, supposedly taken from fighter pilots, of objects moving?
The three. There's three of them, right? Yeah. This is one of the things you have to understand. There's three of them, you know? There's only, and that, so what is it? Go Fast. I can't remember the other names, like LiDAR and one other. So those videos are really intriguing on a certain level, except let's also, you know, you want me as a scientist to digest that as data, and you want to make a claim about what you see in those data, right?
Well, even before you make a claim, how do you as a scientist view that material and start to reconcile it, understanding that you can't make a claim yet because you don't have enough information?
Okay, right? So as a scientist, what I do is I look at that data and I say, what do you want me to do with this data? It's completely digested. I don't know what instrument this came from.
Meaning it's already, so yeah, sorry, it's already been edited. We don't have the raw footage. We also don't know anything. Sorry, I don't mean to answer for you. We don't know anything about, you know, where they've placed the cameras, what the recording was from. And you're also needing to believe, which is why there are scientific standards, you're needing to believe this person, meaning he says this came from that footage on his plane and you have to believe that.
Yeah.
And many things move in weird ways. I don't know that that we will necessarily know why. But go ahead. Sorry.
But that's the rub right there. Like, that's the leap for me, is many things move in weird ways.
No, there's no, those videos do not show them moving in weird ways. So there was like, there was this, somebody looked at the little numbers rolling off on the bottom of the screen, a scientist, and looked at the footage. I think it was the one where it's like zooming over the water, like over the water at 30,000 miles an hour or something. And they looked at it and they did like the simplest thing you could do, parallax, right? And they figured out like, well, based on this analysis, it's moving at 40 miles an hour and it's at 30,000 feet or whatever, 10,000 feet, like a balloon moving in the wind. So this is what happens. You get this amplification where suddenly people are like, these videos show things moving in ways that nobody's ever seen before. No, they don't. They don't. I mean, in some cases, you don't really have even the information you need from that video to tell how it's moving. So it's like the idea that there's proof. So here's what I would say. Based on the same standards of evidence that make your cell phone work, right? If you want to have the standards of evidence that a scientist applies to any problem that they deal with, including all the things that you rely on, there is no evidence that is associated with anything with UFOs that comes even close to the standards by which a scientist would say, oh yes, that thing is moving in a way that, that no physical object could move. It's just not there. But what you've had happen is this, again, like I said, there's 3 videos. There's only those 3 videos, but they get sliced and diced and replayed a million times as if there were zillions of them. There's other videos that people have taken of other things, but they're not, those ones. Let me actually just also make a point here. When we talk about UFOs and UAPs, we have this feeling because of the way social media works that the sky is full of things we can't understand, right? And in fact, even the last, Air Force study of this, where they interviewed a bunch of people and they, did the usual thing of, oh, can we explain this? 96% of all of the reported stuff that they looked at like, I think 800 were explainable. And that's exactly the number that when the Europeans did this, they found it, exactly the number or just about the number that previous studies have shown. So most things that people take videos of or show, are explainable. They're easily explainable. Now, there is that 5% that is freaky deaky, which I think should definitely be studied. But some of that 5% is just, you don't even have enough to start, doing an actual scientific investigation. So I think it's really important to push back on this idea that there's already data out there that a competent scientist could take and show that things are moving in, you could prove that things are moving in weird ways. It's just not true.
One of the most kind of popular, counters to this conversation is, it takes into account the fact that the government lies about things. It takes into account that there's a lot of secretive things. And what I hear from a lot of skeptics, or I don't even know if you call them skeptics, what I hear from a lot of people is like, there are things that the government is probably researching that are not for public consumption. And sometimes pilots will accidentally see them, and we're not going to have the government go explaining them because it's likely regarding defense or something that they're developing that's trying to fight one of the many wars we may be engaging in by the time this episode airs. Right. So there's also this notion that once you have any sort of secrecy or protectiveness, for people who are naturally inclined to believe that there are aliens and that there is something that's being hidden, that's going to sort of exacerbate that. I do wonder because, there's a lot about alien reports. And then I do actually want to get into some of the practicalities of what we actually do study when we study this. But I wonder if, especially given your experience with the Marvel universe and with, kind of a fluency in the culture of science fiction, which does play a big part in this,
right? Fiction, yeah.
I'm fascinated by these stories ever since I was a kid. When I would hear abduction stories, like it was they're fantastical stories, right? It's unbelievable. And, before the internet, you'd hear people reporting very similar imagery, right? And very similar experiences. And how could this be happening? So, what we know is that for all of, kind of human history, there have been, cultural consistencies about fears. and they often, you know, parallel politics, or they parallel environmental occurrences. You know, it's no coincidence that a lot of the science fiction came, you know, after the Cold War, and again, you know, when fears of McCarthyism, you know, things like that. But can you talk a little bit, just also as just sort of like as a human, you know, not necessarily as a scientist, what is happening when people are reporting, you know, being visited by aliens, these abductions? How do you frame that? And then can you also help us with the Fermi paradox understand where some of this interest comes from?
Yeah. Well, there's a couple things I want to say about this. So first of all, just like my own personal experience with this, right? I have had much, you know, when I was a kid, I got into astronomy when I was 5 years old because of my dad's science fiction collection, you know, that I was looking at the covers of. I was so into von Daniken's, you know, The Chariots of the Gods. You know, you guys know that book, right? That was the first Ancient Aliens thing. When I was like in like 5th grade, I read that and I was like, man, this is true. You know, the pyramids and the NASCAR planes, and particularly Easter Island. I was really like, how did they move those giant, you know, stones on Easter Island? And then I remember, like, a year or 2 years later, I'm watching PBS, you know, looking for a science show. And there was a thing called In Search of Ancient Astronauts. And it was basically a bunch of people who actually studied these things, you know, the anthropologists who lived there. And what I found out was that von Daniken's stories were all bullshit. Like and I was so angry. Like he just had never gone to Easter Island to find out, like, oh, you know, the reason why they were able to move why these statues were moved on an island without trees was they cut all the trees down, moving the statues. You know, it was human stupidity, not ancient aliens. I was so angry. I'm from Jersey, right? I'd been fooled. I'd been taken as a mark. And that really affected the rest of my time thinking about UFOs and UAPs, because so much of it has turned out to be hoaxes and bullshit, and people like trying to sell their books or whatever. And, you know, as a scientist, I don't want to, I want to know what's true, you know, and science is my best route for when it comes to the physical world, knowing what's true. And so I do, you'll see me push back hard sometimes on this, just because I think a lot of people are taken advantage of. We all have this interest in the unknown, right? It's beautiful. The world is so beautiful. The world is so luminous. The world is fundamentally mysterious, right? Life and death, what the hell is going on? And so, like you said, there's this cultural, we have these fears, we have this wonder, and we get played upon by people who, want to sell their whatever, or want to gain power, or just want to be someone special. And, science is our best antidote to getting fooled. Right? I don't want to be fooled. I don't want to be fooled in my spiritual practice, in my, my Zen contemplative practice. I don't want to be fooled in my science. And so that's why I sort of push back on this. Knowing whether there's life elsewhere in the universe, knowing whether or not we are the only place where life formed, is the question I really want to have answered before I died. It's the most important question to me that there is. And I don't want to be fooled by, people telling me like, oh yeah, UFOs, there's absolutely UFOs are from other places. So I don't know if that was helpful for that answer.
Yeah.
So, but let's move on to like what we can know, because this is such an amazing moment.
Well, can you talk about the Fermi paradox a little bit?
Yeah, right. So the Fermi often what you get with Fermi paradox, and this is from people who are pessimists about life in the universe. So the Fermi paradox is the basic idea. There's two versions of it. One is, if the universe is teeming with life, intelligent life, why aren't they here now? Like, why aren't we being visited? Right now, why haven't they landed on the White House lawn and said like, hey, we're here, we want to eat you. And then the other version is, we've been looking since 1960 and we haven't seen anything, right? So let's deal with the second one, because often that's the one people think about, like, well, we've been looking forever, haven't we? And that one turns out to also be completely wrong, because for the most mundane reason, right? We never looked. Right? People have this idea that every night scientists take radio telescopes and search the sky for signals of alien intelligence. And it turns out that there was never any money to do that. The giggle factor killed SETI to most part. So my colleague, Jason Wright, he and his students did a study where they counted up all the SETI searches that have ever been done. And the metaphor is, if the sky is an ocean, how much water have we looked through of the ocean? Turns out it's a hot tub. Right? That's how much of the sky we've searched. So like if you dragged up a hot tub's worth of water and you didn't find any fish, are you then going to say like, well, I guess there's no fish in the ocean, right? So there's no Fermi paradox when it comes to we've looked and we haven't found. The Fermi paradox around like how come they haven't landed on the White House lawn? Well, if you're into UAPs, that's the answer, right? They are here. But there's so many other ways to answer that one. Like, people have the zoo hypothesis and the this, that, and the other thing. There's so many ways around why aren't they here right now? I've written a bunch of papers on this. Well, what if they landed? What if they came by 1 billion years ago? There'd be no evidence. There, the Earth, the Earth, it resculpts the surface so dramatically after just a few million years. You're not going to find any pyramids from 1 billion-year-old visitation. So in general, there is no, that's what I want really people to understand, is that there is no Fermi paradox. We've never looked. We just don't know. And now finally, this is the message. We finally can look, after 2,500 years of yelling at each other over our opinions, we finally have the science to look at, if you're interested in aliens, like, so here's my metaphor. If you're interested, if you want to find Nebraskans, right? You want to find some people from Nebraska. Would you go look at a small village in the Himalayas? No, you go to Nebraska because that's where the Nebraskans live. That's the same thing with like UAPs in the Earth. If you want to know about aliens, why are you looking at this backwater planet, us, and expecting they're all here? The place you look for aliens is where they're from, alien planets. And now, finally, we're just on the edge. In the next 10, 20, 30 years, I am sure that we are going to have data relevant to this question. I can't tell you what the data is going to do. I can't tell you what it's going to say, but we are going to have actual factual data that is going to be specifically aimed at, is there any kind of life, microbial or not? And are there any technological civilizations?
One of the things I'd like you to explain before we go into like how we actually look for life on other planets, can you explain a little bit the issue of the scope of the universe? It blew my mind to start thinking about the fact that we have technology that can look at things that are so far away, and like it makes me want to cry. We will never go there. Like we'll never go there, and they will likely not come here, or they haven't come here because it's too far away. But that doesn't mean, like, can you talk a little bit about some of the limitations and start us understanding what technology we have that actually can look even if we can't touch it?
Right. So that's, the thing, I think it's really hard for people to understand unless you really worked at it, is how freaking big space is. I'm just talking about the distance between us and our nearest neighbor. The house next door is so far away. By what I mean by that, the nearest star is so far away that if you traveled at the speed of the fastest thing we've ever built, which is the Voyager probe or the New Horizons probe, which was, went to Pluto, or New Horizons went to Pluto. If we were traveling at that speed, the fastest thing we ever built, it would take 400,000 years just to get to the house next door. Now, remember, we're kind of thinking of the galaxies being like Manhattan. So let's say you live like where I did in Jersey, right? In Belleville, right across the river. That means to get to Brooklyn, it would take tens, if not hundreds of millions of years. So the distance between the stars is so freaking huge that's why people, as I say in the book, you can't just wave your hands at that and say like, oh, of course the aliens have figured it out, right? Because we know that light speed, like right now, our physics tells us, and we know physics pretty well. Sure, there could be more physics, but we know physics. We have some pretty awesome understanding of physics. Light speed is you can't go faster than the speed of light, right? So that means that even at light speed, if you could travel, you can get yourself up to light speed, which we can't even come close. It would take, the nearest star is 4 light years away. It would take 4 years to get there. That's the nearest star. If you want to go down the block, those are 40 light years away. That means it would take 40 years to get there, and that's still our neighborhood. So it's really important for people to understand when dealing with thinking about space and life, is to understand just how vast those distances are between the stars. So we start there.
Yeah. So let's start there. And we've talked a bit about exoplanets. Can Can you talk a bit about, I think let's go into biosignatures and technosignatures.
Right.
Can you explain why it's important for us to understand what we've done to our planet in order to understand how other things could have done that to theirs?
All right, well, let's go to biosignatures first. And it's not us, it's life, right? So the thing about life is that life basically based on Earth's history, when life forms on a planet, it hijacks the planet. It takes over the planet's evolution, right? Life is not some green scruff that's like hiding, in the corners of a planet. It takes over a biosphere, which is the sum total of all the life existing, actually completely takes over the history of the planet. We talked about oxygen. There's a great example. The Earth's atmosphere has 21% oxygen. That's all because of life. If life were to disappear tomorrow, all the microbes and forests and everything, that oxygen would be gone in a pretty short time. It would all react away with the rocks and get locked up again. So if we could detect oxygen in another world, in the atmosphere of another world, that would be a biosignature. Pretty good. We think, there's other things that can happen, but we have the capacity now. We can actually see into the atmospheres of worlds that are 40 light years away, and we can see the fingerprints in the light of what chemical compounds are in the atmosphere. So because life hijacks a planet, takes over the planet, reshapes the planet's evolution, and does things like burps out oxygen into its atmosphere, we can use that oxygen or other compounds that we can see in a distant alien planet's atmosphere to tell whether there's life there. And we just need to stop for a moment and go, holy shit, that is amazing. A bunch of angry hairless monkeys, us, figured out how to see into the air of a distant world and then use that to figure out whether there's alien life there. I mean, that is like, okay, we suck in a lot of ways, but that's pretty good. One for us,
Beyond biosignatures, you talk about things like CFPs, you talk about satellite, you talk about debris. I had never thought that much about what our planet tells aliens, right? Because if something is looking at us, they're not only able to see, oh, there's oxygen, there must be life here, but we have satellites that are floating in the sky. We leave junk in space, right? We leave things on the moon. We leave holes in the ozone layer because of the things that we have done to damage our environment. But those kinds of things, light pollution, right? If something is looking at us with intelligence, they would be able to say there's intelligence on that planet that created that enough. So what that means is we get to do the same to alien planets. We get to say, are there chemicals? Is there satellites? Is there debris? That's the kind of thing we can look for. But again, we're talking about a lot of stars. It takes a lot of scoping this out to try and find this. Can you talk a bit also about like technosignatures?
So, we talked about biosignatures, all the ways in which just, a biosphere, you could have known, if you were looking at Earth 100,000 years ago or 500,000 years ago, before any human beings were here, you could have told, oh, that planet has life on it for sure. There's life happening, but now we are leaving evidence of our technology, of a global technological civilization, what we call a technosphere, all the sum of technology operating on the planet. We're leaving evidence of that. And so so I'm the principal investigator on NASA's first grant ever. This is part of this change that happened. The first grant ever to study the technosignatures of exoplanets. So there's a whole list. Our job is to kind of go through the list and see what's good and what's not good, and then to recommend eventually which ones people should use telescopes to look at. So, okay, let's start with chlorofluorocarbons, CFCs. These are the gases that we used for air conditioning that we escaped, belched out into the atmosphere, which were killing the ozone. You can see those across space. You would be, if there was a planet that was 40 light years away, we showed this in a paper, 40 light years away, and it had the same level of chlorofluorocarbons that we have right now, even with the JWST, the James Webb Space Telescope. you might be able to detect that. If it was 5 times, 10 times higher, we'd definitely be able to detect it. And, people say, well, that's pollution. How do you know they're using it for pollution? They might be using it on purpose. Like chlorofluorocarbons are a great greenhouse gas. If you want to make a planet warmer, let's say we wanted to move to Mars and make it warmer, we pump CFCs into the atmosphere. So certain kinds of atmospheric compounds, which we know nature will never produce, those are technosignatures. Seeing city lights, you could, if a planet has enough urbanization or is using lights for artificial illumination, you could see that across interstellar distances. You might, if you're using solar panels, for solar collection on a large enough scale, the reflection of the light off the solar panels, we could use that as a technosignature. And this is mind blowing, right? I mean, we have finally the capacity to eavesdrop, not even eavesdrop, that's the wrong word. What we're doing is, right, I really want people to understand this. The old version of SETI was we were waiting for a signal, right? The only way the radio version of SETI worked was you needed somebody to be beaming a signal to you, to be announcing their presence. Like, hey, we're here. Look at all our great technology. Look at our art, And that's one of the reasons I didn't pursue SETI. I was like, that seems, I mean, why? How do you know somebody's going to want to send a beacon? The new version, what we call technosignatures, which, classical SETI is still part of. But the new version is we're like detectives, right? We don't care whether anybody's trying to communicate with us. We're just like hanging out in our car with our crappy cold cup of coffee and our shitty donuts. And we're just watching. We're just watching for the civilization to go about its business of civilizationing, right? And we can tell they're doing it. So like all the old stuff gets wiped away. We don't need to care what their motivations are. Oh, they want to contact us. They want to leave an edifice. No, they're just going about their business. And we're sitting there going click, 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 taking our pictures from our car. And so it's an entirely new game that our technology, our theoretical understanding of planets and life, biospheres, technospheres, allows us to do with this. And so that's why soon we're going to have data that's going to help us answer the question whether anything is out there.
Can you explain why we may encounter an alien civilization that could be 1 million years old?
Yeah, well, actually, the odds are that's what we're going to encounter, because you can work out the math. So David Kipping,
You're so casual about this. You're so certain that aliens are not here probing people's butts. But when I say something like, might we meet an alien civilization that's 1 million years old? You're like, of course, Mayim. What are you, stupid?
Yeah, it's a weird world I live in. Listen,
you're a weird dude.
That's what my kids say. So, first of all, about the UAPs, I'm not certain that there's no UAPs here. I'm just saying that there's no, You
get this dichotomy that is confusing about you, in that in one way you're like, they're not here looking to look at what farm ladies are doing, in their kitchen, but 100%, 99.99 with a repeating sign over the 9, we're going to find alien civilizations that are millions of years old.
This brings up standards of evidence, right? Yeah. And how science works. How does science know anything that it knows? Because, we live in a world where there's so much science denialism, and so much. So how does, and yet in the meantime, people are like, well, science is full of crap. They don't know what they're talking about. Give me some more antibiotics. These are so yummy when I'm sick. So it's a really weird world we live in. And I love science. But so my claim about that, about why it has to be older, I can work out, there's the science of probability. There's the science that I know about. There's the numbers I know about how many stars there are. There's the history of the Earth. And that claim comes from doing the mathematics. And I didn't do it. I don't have the kung fu to sort of do that. It was David Kipping at Columbia, who we worked together. I mean, I'm a theoretical physicist, but I don't have his chops. Using what's called Bayesian analysis, which is a way of estimating probabilities based on when you have just a few bits of information, he was able to sort of prove, and other people had done other versions of this, that if you see a civilization, if you get detection of another civilization, because of the overlap in time, the odds are it has to be one that's much older than you, right? It's just kind of simple in a certain way. What are the odds? If let's say humanity only lasts 50 more years, right? So we're only there 50 more years. And we're out looking through the sky, right? And we see stars, you know, lots. You know, if I see a star that's 100 light years away, I'm looking at it 100 when it was 100 years ago. If I'm looking at it 1,000 years ago, I'm 1,000 light years away. I'm looking at it how it was 1,000 years ago. What are the odds if every civilization is 50 years old that I'm just getting the overlap and I'm seeing them, right? In general, odds are I should be if no civilization lasts more than 50 years, in general, when I look, I'm going to see when they're dead. Either they haven't started or they're dead. And so that's the kind of mathematics you can now build out a really formal argument to show you that in general, on average, if you detect a civilization, it probably must have been there for a long time so that when you looked, they were still there.
So for them to look at us, though, they would have to have some pretty sophisticated scanning technology because we've barely been around. I mean, is that part of what the Fermi paradox allows me to understand? Like, we kind of just, like, we arrived at like midnight of the December 31st on the calendar of the universe, right? I mean, not even. So it's like we kind of just got here. So is that also part of the notion that whatever alien civilization we're thinking might be visiting us, they'd have to be tracking and catch us in this like needle's eye of our existence?
No, that's it. And that's what in the paper I did with Gavin Schmidt, where we talked about the Silurian hypothesis, is one of the reasons we were asking the question, how would we know if there was another civilization on Earth 100 million years ago, right? Not that we believed there was one, but we were just saying, like, would you even be able to tell? And what Gavin, as an Earth scientist, was able to sort of show was like, there's no way to know, right? So that could be one of the answers to that first version of the Fermi paradox. Sure, we've been visited, but we were visited 1 billion years ago or 100 million years ago, and all evidence of that is gone, right? So you're right. If you were like, oh my God, there's technological civilization on Earth, you would have to be like right next door and looking right now to know that. If you were, if you were 500 light years away, which is most stars are more than 500 light years away, you'd be looking at Earth and you'd be seeing like, Renaissance Italy, which you wouldn't be able to see, right? There was no way to tell, so it's like, that is exactly the point you're making is exactly right.
I want to talk about Arrival, but go ahead.
Arrival. I love Arrival.
Do you have faith in the future of current Earth's humanity?
The way I answer, I get asked that a lot. And my answer is like, sure, why not? Because what's the alternative? So I've been, one of my first jobs out of I took a year off between between college and graduate work. And I did a lot of, weird jobs, including working as the bouncer at the Rocky Horror Picture Show on 13th Street and 6th Ave. But I ended up working at the Goddard Institute for Space Studies, which is this NASA installation. And this is 1986. And I was doing scientific programming. And they were doing climate change studies. This is 1986. Nobody had heard of climate change. Like I talked to my buddies, they'd be like, bro, we're changing the climate. They'd be like, no way, man. And so I've been tracking this my entire life, right? And I've written a lot on climate change. And, often, I don't know what your listeners are like, but some of the shows I'm on, I'll see, the comments, people be like, well, he had me until he started talking about climate change. So climate change is happening. It's, I'm sorry, there's no way around it. It has nothing to do with any of us and our opinions. It's just Earth science. Because of it's a product of technological civilization, an outcome of having a technological civilization. So, climate change poses probably an existential risk to this kind of technological society. Human beings are not going to go extinct because of it, but we may not have this kind of society where what we're doing right now is possible, or that the food just magically shows up at, my grocery store. And then there's nuclear war. There's AI, which is just coming, which is going to have all kinds of pressures. Not that I think AI, you're going to get a super intelligence that's going to kill us. It's just that we're going to screw ourselves up using AI. So am I hopeful? Like I said, what's the alternative? I do think this is after the reason I did that preamble is I've been talking to people about climate change for 20 years, right? It's been a long time. And what I'm seeing is not good, right? I'm really stunned that basically we've known this is happening, just this one threat. And we're like, whatever. But I do think, because climate change is it's coming. It's already starting. We're already seeing the teaser trailer for climate change. You can only be able to ignore it for so long. So what I think is the next 20, 30, 50 years, we're in for a hard time. We're in for a challenging time. But human beings are very clever. They're very resilient, and they're fundamentally compassionate. As much as we can be,
but they're also really lazy, and they don't want to use a canvas shopping bag.
Yeah, that's true too. But I mean, when things get bad enough, you know, which is where we're headed. I'm sorry, we could have not gone there. There's going to be a lot of suffering, but I think, you know, we'll end up recognizing it, and sometimes that's what evolution requires. You know, you don't evolve unless there's a gun to your head, right? You don't evolve new behaviors unless there's an evolutionary pressure.
We are resilient, but we're not overly good at collaborating on a global scale to move in a particular direction. So that's a little bit of the caveat. I asked the question really because if there are other civilizations out there in the universe, they will have experienced similar problems in the development of their societies. So part of the curiosity of finding and making contact is, are there solutions out there that could help us?
That was the subject of the book before the book you have on your table, which was Light of the Stars, Alien Worlds and the Fate of the Earth. So yeah, I've done a lot of work on the idea of, is the Anthropocene, what we call the Anthropocene, you know, which is climate change, which is all the feedback, right? Our civilization has gotten so powerful that we're feeding back on the Earth, the other Earth systems, atmosphere, oceans, etc. Maybe that's a generic thing. Like, I kind of expect it is. Once you start using so much energy to power your civilization, of course there's feedbacks. Like, what do you expect? And some civilizations learn how to get through that, and some don't. And so, yeah, one reason to think about looking for other civilizations is just, first of all, to know that somebody made it, right? Because, you know, we don't actually know whether a long-term sustainable technological civilization is something that the universe does, right? We know that there's comets, and we know there's black holes, and we know that there are planets with rings, and we know there's biospheres, right? Because we have at least example of one. But how do we know that actually you can have a technological civilization that exists for 1 million years, right? Maybe everybody dies after 200 years, right? They all burn out. So one also reason to do this is just to see, you know, like, does anybody make it? And what do they look like? You know, I mean, I don't mean look like physically, and we'd be able to tell something about this from, you know, the kind of techno signatures we're talking about. What is their technology based on? How are they organized on their planet? So I think, you know, there's also that very important question of, are we going to endure, and what will it take for us to endure?
Adam Frank, it's been such a pleasure to talk to you. We really appreciate you going into all the mystical and possible places, and also the astrobiological ones. This book is a little book of aliens, but I mean, all of your books are really fantastic reading on such a variety of subjects, really surrounding, like, what does make us unique here, and how can we celebrate that uniqueness. Where can people find out more about you?
I'm not using social media very much now.
Good for you.
Yeah, because my mental health, I'd like to keep my mental health. So, right, probably, I'm actually going to be starting a newsletter soon with Beehive, likely. And so that's going to be a place. And, you know, I'll announce that so I still have my account on X. I'm not using it just because of that guy, the Twitter guy, as Bill Burr says. But I am on Blue Sky, and I have a Facebook author page. But I also have if you just Google Adam Frank Science, you'll find my webpage, and that's where I'll be announcing the newsletter. So that's the main place to see what's going on. And then you can see all the books that I've written there,
awesome.
My other articles, other things I've done.
Well, we really, really appreciate your time. This was fantastic. I could talk to you forever about other things, but we really appreciate it. So thank you.
Thank you. This was a super fun conversation. I love doing this. So thanks, guys.
I didn't even get to point out that I was wearing my Cats in Space t-shirt for this episode.
If you're just listening, it's cats being sucked up by a UFO. I think we've
in
worn
Sedona.
Yeah, I think we've worn it once before.
I wear it for all of our alien-themed episodes.
Oh, you wore it with Lou?
Yeah. There's aliens. There's totally aliens. He doesn't like to say it like that, but there's aliens. What? There's intelligent life. There has to be intelligent life in the universe, and he said it.
I didn't get to ask this, and I'll ask you.
Ask me, and I'll pretend to be him.
Okay, Adam, Why do you think you like sci-fi so much?
I can't answer that for him. It's in the book. He talks about it in the book. I think that there's a real, beauty in what we can imagine. And sure, fantasy is fun, but science fiction's more fun because it's fantasy rooted in the kind of vernacular of science. It doesn't mean that it is scientific, and you can create anything you want. That's the kind of fantasy part. But the fact is we're wired to wonder about the universe. And he said for thousands of years on this planet, people have looked up at the stars and tried to figure it out. What's going on? What is it? I mean, that's what astronomy was. That's what astrology emerged from, right?
There are so many people on this earth that look up at the stars and have this wonder and this sense that we couldn't possibly be alone in the universe. Is that just a creative figment of our imagination? And
I think it's a deep knowing.
That's where I'm going, is that there are so many times that we've seen in the history of human civilization where a deep creative knowing has then transformed into scientific understanding, and that the tools of science catch up to this deep inner knowing that we have. And given how broad the knowing is, it's hard for me to imagine that it's purely for no reason.
I mean, maybe just we've manifested the possibility that there's life on other planets. But I think there's a deep knowing. And while religion ruled astronomy for much of human history, I think there also is this sort of knowing that while there will always be people who believe we're special, God made us this way, that's the whole purpose, I think God created the whole universe with everything in it.
Do you think we can eventually be a multi-planetary species?
With the scientific limitations that I understand of, for example, how we can travel, or even the fastest we are able to travel.
Right now,
right now, like until we can punch it Chewy and like have warp speed. Yeah, I don't think that's possible. But for me, even if we are able to look deep into space and see a biosignature or a technosignature, that's going to happen. I believe that may happen in my children's lifetime, and they will be very, very, very disappointed that Mama was right.
Well, they don't like traveling just on road trips now. They're not going to want to get on the spaceship and take the time to go to another planet. No,
but just the knowledge, like, as he said, like although it's not going to be like the movie Arrival, which we didn't get to talk about, which Adam's a big fan of, and I am as well. It's not going to be like that. And it likely is not going to be like what a lot of people perceive as visits and observations. For For those of you watching, something just came out of Jonathan's neck that looks like a black piece of plastic.
It was from my microphone.
It looked like Jonathan just spawned a piece of plastic as I was describing aliens.
Pulled out of my neck.
I think we'll end there. From our breakdown to the one we hope you never have. We'll see you next time.
It's Mayim and Bialik's breakdown. She's gonna break it down for you. She's got a neuroscience PhD or two. One fiction, and now she's gonna break down